Morning all. In our last lecture, we discussed about B trees. Today we are going to discuss B plus tree. Actually, B plus tree is a variation of B tree data structure. Most implementation of a dynamic multi-level index use a variation of B tree, which is known as B plus tree. Let us rewind what is B tree once again. B tree structure once again. The B tree structure, a structure of a node in the B tree is like this. This is a structure used for root as well as intermediate as well as leaf node. Same structure for all the three levels of node, root, intermediate as well as leaf node. Only difference is that in the case of leaf node, these three pointers are having null values. Now in the case of any root or intermediate node, the structure is like this: P1 up to PQ number of tree pointers and Q minus 1 number of data values. Data value here means data value and associated data pointer. What is the data pointer here is this points to the block which contain this particular record. This particular record, that is what the pointer. And whenever you want to search for a key, then you have to take a path like this: ki minus 1 less than x less than ki. Let x is a search field that we are looking for, then you have to take a path which is which is in between ki minus. Ki is a key value, ki is another key, ki minus 1 ki is another key value in between a path. That path you have to take. For example, if you want to search 6, then you will take this path and you can find here. The structure is same, only difference is that leaf node are the pointer is not, and no connection in between the node in the case of leaf node. And now we will see what is difference. In the case of B plus C, the difference is that this pair, instead of this pair, the root as well as intermediate node, this pair is not there. Only the pair of node, key value pointer pair, will appear only in the leaf, and also the leaf nodes are connected together. That's what a difference between a B tree and B plus tree. Now let us see B tree once again. B plus tree. In a B tree, every search key value appears once at some level in the tree along with the data pointer. But in B plus tree, the data pointers are stored only at the leaf node of the tree. Hence, the structure of leaf node differ from the structure of internal nodes. The leaf node have an entry for every value of the search field along with the data pointer to the record if the search field is a key field. For a non-key search field, the pointer points to a block containing pointers to the data file records. That means if it is a search key value, then data pointer point to the block containing the record. If it is a non-key value, then there could be more than one entry because it's not a key field, may not be unique. In that case, again the data pointer points to the block which contain this given key value. The leaf nodes of B tree are linked together to provide sequential access on search key value. This is a structure of this is a structure of root as well as intermediate node, and this is the structure of leaf node. The difference is that here there is the similarities here is P1 up to PQ, Q number of tree pointers, that is same in the case of B tree as well as in the case of B plus tree. K1 up to KQ minus 1, that is also the same in the case of B tree as well as B plus tree. Number of key values is same, but only difference is that here no key value data pointer pair in the case of root as well as intermediate node. Only in the leaf node this pair appears. Okay, and the search value for a given value, this is ki minus 1, key value ki minus 1 less than x less than or equal to ki. That is the difference. In the previous B tree case, it was ki minus 1 less than x less than k. Now it is less than or equal to, because these values are also appearing in the leaf node also. Because in the case of B tree, a search key value will appear only once, but in the tree, but in the case of B plus tree it can appear in more than one place. That may be intermediate, maybe in the root node, intermediate node, or in the leaf node. In some other place also it can appear more than one place. Okay, now the structure, I think structure is clear now. The same, and there is a pointer. What is P next? P next is a pointer to the next node. That means here another difference is that nodes in the leaf are linked together. What is the advantage of linking together all the nodes in the leaf? The K1, K2 up to KQ minus 1 are in increasing order. The next node means the values will be in another increasing order, maybe and its value will be greater than this KQ minus 1. Therefore, if you arrange all these nodes linked together, this will act like a linked list. All key values will be in increasing order. You can perform a linear search there, a sequential linear search in the leaf nodes. So the structure of B plus tree. A B plus tree of order P can be defined as follows. The internal node of the tree is of the form P1 K1, P2 K2 up to PQ minus 1, K Q minus 1 and PQ, that we already discussed. Within each node K1 is less than K2 is less than, that is the keys are in increasing order. For a search key value X in the subtree pointed by P at Pi, we have Ki minus 1 less than X less than or equal to Ki, and this is the case for 1 less than I less than Q. For I is equal to 1, this is X is less than or equal to Ki, and Ki minus 1 less than or equal to for I is equal to Q. That is already explained from the figure. Each internal node has at most P tree pointers. Each internal node can have at the most P tree pointers. Each internal node except the root and the leaf node has at least P by 2. This condition is same in the case of B tree as well as in the B plus tree. The root node has at least 2 tree pointers unless it is the only node in the tree. This condition is same for B tree and B plus tree. A node with the Q tree pointers, Q less than P, has Q minus 1 search key value. These point number 5, 6, this one point number 3, only the slight difference. This is less than or equal to, no the difference, and the first point there is the pair, that is the difference. Now the structure of B plus tree, the leaf node having the structure Ki PR1, K2 PR2 like that, and what is the last one is a pointer to the next node. This PR is indicating data pointers, and within the leaf node K1 is less than K2, that ordering must be the same as that, same in the case of leaf, root as well as intermediate node. This key value ordering should be the same, and each leaf node has at least P by 2. The condition here is leaf as well as intermediate node should at least have P by 2. In the case of 4, let us P is 4, means the number of data values or key values should be 2 at least. All the leaf nodes are the same level, this condition. Now let us check what is the number of entries possible in a B plus tree, and that is compared with the B tree also. In the case of B plus tree, as already mentioned, that there is no data pointer. Because of the lack of data pointer, B plus tree is more compact. In a given block, you can have more entries than a B tree. Let us check that one. Suppose that the search key field V is equal to 9 bytes long, the disk block having 512 bytes, a record pointer having 7 data record pointer having 7 bytes, and block pointer, that is tree pointer, 6 bytes. Each internal B plus tree node have at most P tree pointers and P minus 1 search key values. Therefore, what is the equation? P into P means number of tree pointers into the size of tree pointer plus P minus 1 into V. V is the size of data or key value. it is equal to 6p into 6 is the size of tree pointer and 9 is the size of 9 bytes is the size of the data key value. P minus 1 into this is equation. That is why you will get 34. When compared to B tree, it was 23 only. Why the difference? There each node there is a data pointer, each key value associated with each key value there was a data pointer to. Because of that, more number of entries is possible in a given node. A node with size 512 bytes can have 34 is the number of entries in the block. Number of root as well as intermediate node. For leaf node of the B tree, what is the size? P leaf, number of leaf entries is equal to leaf entries into PR plus B. Here there is data pointer, that is why PR comes. That is 7 is a bytes required and 9 is a key field size. And what is 6? 6 is the tree point or the node point next to pointing is the next node. Now you got 31. Therefore, from this result, what is our conclusion? A B plus tree is more compact. A more number of entries is possible in the case of B plus tree than compared with B tree because of lack of data pointer in each intermediate as well as root nodes. Now let us see a B plus tree insertion that we will see in next class.